So ladies and gentlemen, are you enjoying so far? Doesn't seem like. Little louder, please. Are you enjoying? Perfect. Just one question from my side. Have you ever used database in your learning journey? Hands up if you have. Everyone? Yes, definitely. That was expected. So we have used databases in our learning journey. But what we did was on-premise. Now it's time to learn from Mr. Pritam that how an enterprise database migration is done, and he will talk about Alloy DB. So let's give a warm welcome to Mr. Pritam.
Can you hear me? Yeah, okay. So let me start with something interesting. Why we're trying to move to cloud, right? So there has to be some significant reasons and some choices has been made, right? When you look at customers or partners or developers looking at cloud. So one is intensive operations. When you look at database, the backend is still the infrastructure, right? You manage the databases, patch the databases, manage the security updates, the OS level patching, the infrastructure maintenance. All this is a burden on the database guy. If you ask a database guy, people like me who have spent around 17 to 18 years in the world of databases, data warehouse, and to extent of analytics, it was a mere pain area, right? And those systems have a challenge of scaling. When you scale, talk about, it doesn't have the flexibility of cloud to scale, right? In cloud, you can easily scale, and it is elastic. You can go up and down, vertically, horizontally, anywhere, right? But about on-premise, you have a rigid system. If you want to scale, you end up buying a new system, as simple as that. And of course, the cost. So there are two ways to look at cost on cloud. Anything extra is a penalty. Very transparently telling you, coming from cloud background of 8-9 years. And whatever you require is a benefit to the cloud. But on-prem, you had the luxury, right? You bought server of, let's say, 16 vCPUs or 32 vCPUs or other cores. But in cloud, you will have to do justice of using those vCPUs, we call it, right? So in that way, we had those thing, right? And if you look at traditional database technologies, they are proprietary technologies. I will talk about that as we move into Alloy DB. So behind every successful application is a great database. You agree or disagree? If your application is up, wow, that's good. If the database is down, the application makes no sense, right? You agree? No, disagree? Okay, great. So the great customer experience comes from great applications backed by databases. And people forget about the databases, right? They say database is just a commodity product, but if data is not available, then the entire thing goes for a toss. Enterprises, business, anything, right? So I will leave this slide away. You can see the Gartner Magic Quadrant. So this is the entire portfolio which you see on Google Cloud. From left to right, if you are looking for memory like Redis or Memcached to accelerate the performance, we have Cloud Memory Store. If you want to bring in the legacy Oracle database workload, we have got bare metal services. If you are looking to run like managed service for SQL Server, Postgres, and MySQL, we give you Cloud SQL. I will talk about Postgres slightly later, my favorite topic of Alloy DB, which is coming, so we'll park it for now. But if you are looking for something like horizontally scalable distributed architecture, we have something called Spanner. And this Spanner has got one of the largest footprint, if not the largest, one of the largest footprint with around 5 exabytes of transactions at peak. So that's the massive scale we are talking about. Where it is useful in the gaming, retail, and in the financial segment as well. The best part is it has got your asset semantics. If you are coming from a database background, you know atomicity, consistency, isolocity, durability, right? That's the ACID semantics. But it brings the value of NoSQL to it also, which is very rare to find on any vendor, either any database vendor or any CSPs as well. So other one is Firestore. It's the NoSQL. We have two offerings, Firestore and Bigtable. Firestore, if you are a mobile user especially, and looking to get started on document-oriented database, mobile apps, especially web application, and looking for live synchronization. If you are coming from AWS background, mobile hub you can think of. So Firebase, Firestore, very closely related, that can help you get started on the document-oriented. And my favorite one, Bigtable. So if you have used Gmail, YouTube, Maps, that means you have used Bigtable in the background. It's a NoSQL database, a wide column store, key value database. And it has got around 12 exabytes of that much massive amount of data at peak per second. You can understand what's the scale we are handling, right? And hardly you have heard YouTube has gone down or Maps has gone down. So in the interest of time, I will skip. So let's see what are the challenges. Anybody want to highlight what challenges you see in the database migration? You must have done database migration, right? It's not like a VM migration or application migration. Any take? No? Okay. See, the very reason of database migration fails is we rely too much on tools. Tools are important, but the problem is we start identifying the tools first without the approach. We don't follow the approach. What we do, we go to a source database, we do backup, traditional way, and then go to the new database, wherever, on-prem or on the cloud, do restore. Or we go to one tool, search in the web, Google search it, and find that database, okay, it can do from source A to source destination B, and then we do it, right? But what you will realize, you go very far in the migration and realize that it has failed because of n number of reasons. So to have a sorted approach or a comprehensive approach is very important. So like for VM migration you do, database migration it's very complex. It's not like a vanilla VM migration, right? You will migrate like a VM migration, database won't work that way. So we do three-step approach. The first one is discovery. When we go to customers or developers or partners, what we do is we talk to them, understand what is the business case. Not everything, of course, top 2-3 use case they're trying to solve for. And once they do it, then what we do is we go and make them aware about Google databases. We saw that last slide, 6-7 flavors, right? So customer may find overwhelming saying that I need Bigtable, Spanner, Alloy, Cloud SQL, what? I don't know. They might be talking AWS lingos as well, RDS, or they might be talking about Azure lingos. So it is very important to make them aware. And then do scoping and assessment. This is very important because scoping is the stage where you try to understand the data state of the database. What it means is, what is the source database? What is the connecting applications? Because you want to move the database, you will also have to move the application, right? Otherwise, there will be a latency and the end user experience is going to be horrifyingly bad, right? So in that way, we call it data state. So this, we have tools. You heard from EPAM, right? They have got a very good tool called Migvisor. So that tool can analyze most of the relational database like SQL Server, Oracle, MySQL, Postgres, and give you the target path on Google Cloud, whether Cloud SQL is good, or Spanner is good, or AlloyDB is good. So that's how we try to do it. And then we go to the tool approach, migration and planning, which is primarily sprint-wise, phase-wise, no big bang approach. So I always push back to the customers and partners when they come to me and saying that, hey, I want to do big bang approach of 20 terabytes of data. So I say, let's start small and see if something is working fine or not, right? So these are the tools we have from Google. So when you say from Google, we have in-house tool, first-party tool, as well as we have tools from our partners. We call it strong partner ecosystem, ISVs, independent software vendors, and some in-house tools as well. So Migvisor, my favorite one, I have been using this tool for a lot. So that's the tool for assessment, understanding the complexity. Let's say you are migrating from source database of Oracle to Postgres, because that's the nearest, target, right? People look at, database guys look at rather. So what they do is, it identifies database configurations, what are the database semantics, beyond the normal vCPU's cores, right? Metadata, schema details. It gives you those details. Similarly, schema code conversion, we have tools like Ora to PG, that's open source. Everybody must be knowing it. Then DMS, the tool from Google Cloud. If you are migrating from like to like, especially homogeneous migration, not cross-platform, DMS is the first-party tool from Google Cloud, and very good tool to migrate MySQL to MySQL on Cloud SQL, or Postgres to Postgres on Cloud SQL, or even AlloyDB. That is also possible. And the last piece is the easier piece. Why I say easier piece is moving the data is not the ultimate goal, right? You will have to make the target and source compatible at the end of the day. So data movement, we have Stream. Stream is our partner. Debezium, you must have heard open source tool as a developer, right? HVR is one of the partner as well. DataStream is in-house tool, and DMS, Database Migration Service, is also in-house tool. And DMS is free service. And in case you want to use the tool, reach out to your Google counterparts, and they can help you get started. So I can extend by 3 more minutes, right? Yeah. So we heard about the first part, database migration. Hope it give you some insights on how it looks like to migrate, right? Tools are good, but if the approach is not there, then the migration fails, right? And it leads to a bad experience, saying that it doesn't work. So let's start with the second section, exciting part. So when you talk about the databases, commercial grade databases, especially Oracle DB2 SQL Server, they have their own pros as well, no doubt about it, and they have created the database industry, right? Let's not forget about it. I am from ex-Oracle as well, ex-SAP, I have used Sybase databases, so I know the power of that. But that comes with a lot of cost. When you say cost, the license cost, right? Enterprise edition, and again, top of that, Oracle, if you go with options like in-memory column store, or partitioning, tuning and diagnostic packs, that's the extra money. Then, each year you have to pay AMC cost. That is around 22%. Think about that money, right? So it's a big pain for the customers, and they want to move about. But saying this, if you look at moving out is not easy, because those are proprietary grade vendor logged in databases. And they provide scale, performance, manageability, and real-time insights. So can any database give you that option on cloud? So on Google Cloud, we have that option with AlloyDB. So if you look at Alloy, literally meaning of Alloy is what? Anybody want to take a guess? What does Alloy mean? I can't hear. Any guesses? No? Okay. So if you Google Alloy meaning, what it means is basically you are trying to melt and do a fusion of 2 or more things, right? To bring out output, a new metal or something new which has better capabilities. So that's the name AlloyDB came in, and it has got the Postgres. We are Postgres first approach, cloud native approach, we follow that. And awesome engineering team, because we have got all the peoples coming from different backgrounds, likes of Oracle, SQL Server, MySQL, Postgres, as an entire team, plus and Google's excellence on DNA of AIML. So these 4 capabilities gives you the AlloyDB in a nutshell. So why AlloyDB? So when you look at Postgres, we have Cloud SQL already. But The idea was, can we have a database which can match the commercial grade databases, but with better price and performance match? So that's how we wanted to get started. So that's how we came with AlloyDB, and we can give you 4x faster performance on the transactions. So when you say transactions, OLTP. So typically if you online transaction, we call it OLTP workloads, right? And 2x faster than the Amazon compatriot like your Aurora. If you are used Aurora, Postgres flavor, this AlloyDB is 2x faster than that. If you have used self-managed Postgres, it is 4x faster. And if you look at traditionally databases, there is a combination of workload, right? It's not like only OLTP. It is also with operational analytics, right? So that's the reason we mix the analytics also, giving the customer by introducing an in-memory column store. We don't say we started it, but we trying to revolutionize it and make it better for our customers. As a result, it can give you 100x faster columnar things. Like if you want to do select queries, it will give you faster response. And without writing any storage costly indexes. So that's the best part of the AlloyDB. Okay, this is the last architecture slide, how it works. So when you look at on this slide, you have the primary write, right? It has got one primary read write, and it can scale up to 20 read replicas. And how the primary keeps a sync with the read replicas with the help of wall records, right? In Postgres, we have something called wall records. If you are used Postgres, write ahead records, right? So those records are streamed from the cache of the primary to the replicas. If the replica is 5, 4, 10, 20, whatever, it does that. And what have you done is differently, we have disaggregated compute from the storage. So the benefit is when you look at our Google products, like whether it's Spanner, BigQuery, Bigtable, compute is always separated from storage so that each can scale independently. And as a result, we don't want to lose out the elasticity and the scale. We can provide that massive thing. And even the storage engine in the middle you see, it is optimized for Postgres so that we can reduce the IO bottleneck, hotspots, and everything. And then we have Colossus. If you used YouTube, Gmail, any of the Google databases, Colossus is your file system. And hardly you have heard, right? YouTube going down, right? Imagine the scale it provides. So that's the beauty of this AlloyDB, which can use this storage capability at scale. And this slide, I know, I'm just up. So this slide is about the comparison. I'll just take few seconds. So Cloud SQL, think of Cloud SQL where you need only OLTP transactions. And you want Postgres flavor of, let's say, Postgres 9, 10, 11, 12, 13, 14. AlloyDB, only Postgres 14. We will keep with the latest release of 14, where you want a workload of OLTP plus OLAP. Spanner, if you want multiple primary read-write. Because Cloud SQL and AlloyDB, they have only one primary read-write. But in Spanner, you have multiple primary read-write. Then you can go there. Of course, BigQuery is the data warehouse, and it can scale massively. And to talk about the scale, it is an exabyte scalable cloud-native data warehouse. With this, I would like to end, and thank you for patience.
Thank you so much, sir, for sharing your insights on enterprise data migration and AlloyDB. Your session has provided us with valuable guidance on approaching on how to approach on complex database. We appreciate your expertise and experience in this field.
I would request Mr. Sri Bhagwat to felicitate Mr. Pritam Sahoo, sir.